Hey guys, here's an FAQ on momentum and impulse, and also a little bit of simple harmonic motion. Let's have a look at the question. So here's a bullet. So this is your body one. Let me rewrite this. So here's your body one, which is a bullet that is fired from a gun of mass m and velocity v. It is colliding or it is undergoing collision with the second body, which is a block of mass capital M, which is initially at rest, which means its velocity v initially is going to be 0. Let's call this v and let's call this vm. Now, they say that it is connected to the end of an ideal spring on a frictionless table. So frictional force Fr is 0. Don't need to worry about friction here. At the moment that the bullet hits, the spring is at its natural length L. Now, the bullet becomes embedded in the block and simple harmonic motion result. I think they mean that it results in simple harmonic motion. So part A, determine the speed of the block immediately after the impact by the bullet. To do this or to solve part A, we're going to use conservation of linear momentum in one dimension. So when two bodies M1 and M2 with initial velocities V1 and V2 undergo a collision, changing their velocities, we write the equation as m1, their initial velocity is u1 plus m2 u2 is equivalent to m1 v1 plus m2 v2. Now, in the question, they have told that the bodies do collide and the bullet gets emitted, which means both the masses combine to form a single mass. So my substitutions are as such: m into v as given here plus capital M into 0 again as given here is equal to the combined masses M plus capital M into, let's call this V dash or V after. So rewriting the equation in terms of velocity after collision, I get the equation to be small m into V divided by small m plus capital M. Now, moving on to part B of the question. The part A is done. Moving on to part B, determine the amplitude of the resulting oscillation. So they say amplitude, they essentially mean the displacement, or I would say the extension length, or I would say in this case, the compression length X, let's call it, or X naught. Let me call this X naught. The compression length X naught of the spring. Now, let's talk about energy transfer for a second here. So the body 1 and body 2 have energy in the form of kinetic or kinetic energy. This is converted into two forms. One is elastic potential energy of the spring plus work done against friction. This is the different forms in which energy is converted in the question. Now, they have told that friction is 0, which means work done against friction is 0, which means the entire kinetic energy is converted into elastic potential energy. Kinetic energy has a general formula half mv square. So that's half times the combined mass, which is m plus capital M into v square, which is the square of this entire equation. Let's call this v after the whole square. This is equal to elastic potential energy, or the spring has a formula half k x naught square, where x naught is the extension or the compression length. So that's half spring constant k into x naught the whole square. I can rewrite this equation in terms of x naught. Get the equation as x naught is equal to, so the half and the half will cancel. X naught is equal to square root I think if I substitute V naught as mv divided by m plus m, I can cancel one of the values there. So I get small m into V divided by small m plus capital M into K, whole under the square root. Now, compute the frequency. So part C asks us to compute the frequency. It is very easy to calculate frequency in simple harmonic motion. Since this is a horizontal spring mass system, so we know that in a horizontal spring mass system, time period T is 2 pi square root mass by spring constant K. And since frequency is 1 by time period, I should rewrite it as frequency F is equal to 1 by 2 pi square root spring constant K divided by mass M, giving me the substitutions for this specific equation as 1 by 2 pi square root of the spring constant K divided by the combined mass small m plus capital M. Now, there I have an equation which gives the position of the block as a function of time. So we know that the spring equation can be written in general. The equation is x equals x naught. Let me rewrite this. X equals x naught sine omega t, where omega is 2 pi f. So making the substitutions for this, I can write the equation for part D. And the phase difference is 0. The reason I know phase difference is 0 is because they say that it is originally at its natural length, which means there is no phase difference. Simple reason, at time t equal to 0, I'm going to have my x value also to be 0, which is an indication that there is no phase difference. The final equation is going to be x equals x naught, which is this entire equation. Small m, small v divided by small m plus capital M. This is my x naught or the amplitude multiplied by sine omega. So omega is 2 pi f. So 2 pi cancel. I'm just left with square root of k divided by small m plus capital M, times t. So this is the final equation for simple harmonic motion. This concludes all the four subsections to the question. Have a great time, guys. Thank you.